Phasor means a rotating vector. The AC voltage and AC current, we know, it changes its magnitude in a sinusoidal manner. So to represent their phase relationship at any instant, we use phasors. In phasor representation, a physical quantity which is a scalar, it is represented as a rotating vector. The length of that vector is taken to be the amplitude of that sinusoidally varying quantity, and it rotates with an angular velocity omega. Therefore, at an instant the angle swept is theta equal to omega t. Now when it rotates, so for example we will take this phasor to be phasor V, which represents voltage, AC voltage. We know the AC voltage is V equal to Vm sin omega t. So we take the length of the phasor to be Vm. The amplitude of voltage is Vm. So length of the phasor we are taking as Vm. And when it rotates, how it represents Vm sin omega t is this. That means we have to take the projection of this vector on y-axis. How we take projection? Just drop perpendicular from the tip of the vector onto y-axis. So that distance on y-axis gives the projection. So let's see what is that projection. So on the y-axis that distance is the same as in that diagram the distance we represent on the other side, this distance. Okay, so from that triangle, if we take sine theta, that means sine omega t, if we represent that distance as y, we know y is equal to Vm divided, that means sine omega t equal to y divided by Vm, or y is equal to Vm sin omega t. Like that we will be getting from the diagram. And we know Vm sin omega t is what that's what we say like this. That means when the phasor, when it rotates about the origin, the projection on y-axis represents an alternating voltage or alternating current. So this method we use to represent a scalar quantity which is varying sinusoidally. This is how when the phasor rotates about the origin, it generates a sinusoidally varying function. As it keeps on rotating, the function is continued, like that means, for example, we stated V equal to Vm sin omega t. So in the same way we can represent current also in this manner. So in short, when the phasor rotates about an origin, the rotation of the phasor generates sinusoidal functions like V equal to Vm sin omega t and I equal to Im sin omega t. When AC is connected to a resistor, we know the resulting voltage and current, they are in phase. There is no phase difference between voltage and current. So those two phasors, they are represented as shown in figure. That means both the voltage and current, they are along the same direction. That blue line stands for voltage and pink line stands for current. And as they rotate, this is how they generate that voltage and current. So this is the phasor diagram representation. So at any moment, the projection on y-axis, it gives Vm sin omega t and Im sin omega t. This is the phasor diagram given in the textbook. So in the case of AC given to an inductor, there is a phase difference of pi by 2 between the voltage and current is lagging behind the voltage by an angle pi by 2. So when we draw the phasor diagram, first we have to draw voltage. And we know the direction of rotation is like this. Anti-clockwise direction is the direction of rotation. So any lag means we have to show the current in the below quadrant, that means fourth quadrant, we have to represent the current, and the angle by which it lags, current lags, it is pi by 2. So the angle between the current phasor and the voltage phasor should be 90 degree or pi by 2 radian. So this is how we represent voltage and current phasors. That means this is the voltage phasor and this is the current phasor. Okay, so that the angle between the two, it is 90 degree. The length we have shown differently, which is understood that the amplitudes of voltage and current will be different. We know the voltage and current, when an inductor is connected to an AC, they are having a phase difference of pi by 2. Here, current lags behind the voltage by an angle pi by 2. So, to represent current, that means the two vectors, the two phasors are represented like this, that violet line stands for voltage and that pink line or red line stands for current. So as it rotates, as they rotate, they generate Vm sin omega t and Im sin omega t minus pi by 2. This is the phasor diagram given in the textbook. When AC is given to a capacitor, we know voltage and current, they differ in phase by pi by 2, but here current leads the voltage by an angle pi by 2. So when we draw the phasor diagram, first as we said, we represent voltage, this is the voltage, and current, we know it is leading the voltage, so that it should come in the second quadrant. So current is shown like this. So this is how we represent voltage and current phasors when a capacitor is connected to AC. So as we said, current leads the voltage by an angle pi by 2. So when both the phasors, when they rotate, they generate this alternately varying functions as given. This is the phasor diagram given in the textbook.